Welcome class. In continuation of our discussion, Integrated Logistics 1, I'm presenting a few more issues related with integrating logistics. Now, mostly our discussion today will be based on the cost aspects. In the first integrated logistics context, we discussed mostly our focus was on the customer responsiveness. So, whenever we talk about any balanced integrated logistics decision, which needs to be or which is in balance of cost efficiency at one end and customer responsiveness at the other end. So our earlier discussion, we mostly concentrated on the customer responsiveness in terms of warehousing decision, location decisions, in terms of procurement driver decision, and also market distribution, manufacturing decisions, right? So today our focus of integrated logistics in the context of cost minimization strategy. And what kind of trade-off relationship is existing with cost minimizing versus a customer responsiveness? See, normally we say what is the total cost, because integrated logistics where a total cost integration is also we need to consider as one part or one important critical component of deciding the better logistics strategy. Economic forces like transportation inventory, which decides or determine a firm's most appropriate network of warehouse facility. And specifically, if you look into the economics related issues in the transportation, the key to achieve economical transportation is based on two principles. One is the quantity principle, that is, the individual shipment should be as large as possible so that which will involve the carrier can legally transport in the equipment being used. So the quantity base, more the quantity in one single transport ship time, which will reduce the total cost. Okay. The second, often called as tapering principle, large shipment should be transported distances as long as possible. So first one, we talk more on quantity aspect. Second one, we talk more on let the quantity be less, but the longer distance it covers in a single shipment. So both are providing trade-off cost economy, specifically in the context of transportation. So economies of transportation consolidation must justify establishment of a single warehouse, or maybe we need a network of warehouses, right? So how do we do the justification of cost-based warehouses? The basic economic principle justifying establishment of a warehouse is transportation consolidation. Unless a firm is strongly deciding what kind of transportation mode and the strategy they are going with, which will influence the type of warehouse they are keeping. Manufacturers typically sell products over a broad geographical market area. If customer order tend to be small, then the potential cost saving of consolidated transportation may provide economic justification for establishing a warehouse. I'll give you an example. Say a manufacturer's average shipment size is 500 kilogram, 500 kgs or something. And the appreciable freight rate is rupees 7 rupees or 10 rupees per 100 weight, per gram weight. Okay. So each shipment may direct from the manufacturing location to the market. So totally it may go up to multiplication of 500 into 10, 5,000. The quantity or volume of transportation rate are greater. So this calculation will give us a clear indication what type of cost transport economy the company has to choose it. So this kind of economic relationship, establishment of a warehouse, offers potential to reduce the total logistics cost. That's the ultimate aim of any integrated logistics cost-based decision. Then now we move on to the inventory part of economics. Inventory level in logistics system directly relates to the location network. The framework for planning inventory deployment is normally we call it as a performance cycle. The key driver, though we discussed the transportation economics as one of the primary driver, the key driver of inventory economics is time. It is a forward deployment of inventory in a logistical system potentially improves the service response time. So service-based warehouse should be going for service-based, time-based or cost-based. So whatever the decision the company is taking, the base stock level within the logistics system, which has to be kept, which is determined by manufacturing and transportation lot sizes, which do not change as a function as the number of warehouses whatever we have. So whatever the decision of a warehouse model, whatever be the decision of a transport mode or choice, this number of shipments, the combination of maintenance of ordering costs adjusted to take consideration into volume of transportation rate and purchase discounts, this will really determine the replenishment of economic order quantity. And the company also has to keep certain average stock inventory to manage any kind of safety stocks, also to manage any kind of unexpected demand from the customer end. So this way the inventory economics is equally important. And then now we move to total cost network, how the trade-off relationship is really getting the minimum total cost point for the system is not at the point of least cost either for transportation or inventory. This is the hallmark of our integrated logistic analysis. In actual practice, it is difficult to identify and measure all aspects of total logistics cost. Many assumptions are required to find out the best least possible cost and the best possible service. So we may go with certain critical assumptions and limitations when we reach to arrive a common optimizing cost-based logistic decision. The transportation requirements are represented by a single average size shipment. In actual operation, it is likely to simplifying assumptions are generally valid. So first what we need to do is find out nature of logistical network design. It is not a short-term planning, it's a long-term planning. When facility decisions are clear, right, the planning horizon extends to maybe how many years within which we are completing, and then the actual shipment size, order size. So all these are all part of contributing, finding out the trade-off between cost and the inventory cost, transportation costs. Inventory cost is normally considered as a function of the number of warehouses is directly related to the desired level of inventory availability. So if no safety stock is maintained in the system, total inventory requirement is limited to base and transit stock. So under no safety stock situation, the total least cost for the system would be the lowest total transportation costs. So to make it very clear, I'm just repeating the words. Assumptions made with respect to desired inventory availability and fill rate are essential to trade-off analysis and have a significant impact on the least total cost design solution. So this kind of desired inventory availability and the fill rate, which only will provide us a clear understanding of how you can minimize the inventory cost and the transportation cost, which has direct impact on the total logistics cost. I hope this discussion will make you understand the basic impact of cost, specifically the inventory and the transportation, in arriving at total cost. So how to formulate a logistical strategy then? So to finalize the logistical strategy, it is necessary to evaluate the relationship between alternative customer service level and their associated cost. While substantial difficulties exist in the measurement of finding out which one is a perfect ideal logistics system design. So how do we do that? So maybe there are 4 different ways through which we can find out the best logistical system. Determining the least total cost network, measuring the threshold service availability and the capacity associated with the least total cost system design, conducting a sensitivity analysis related to incremental service and cost delivery, which affects the revenue generation, and finalizing the total plan. This is the way normally companies are deciding, formulating, devising a integrated logistical strategy. So on this, I'm just going to have some kind of discussion with you. One is, whenever we think of first primary thing which comes to our mind is cost minimization. Just as a physical replication of a geographical area, right? The economic map, whenever we talk about the peak cost, might be in the labor, essential services. So any strategy of least total cost seeks a logistical system or a network with lowest fixed and variable cost. So we need to evolve a logistic system design to achieve the least possible total cost. And also, cost doesn't mean cost involved with inventory, cost involved with warehousing, cost involved with transportation. All this put together, whatever the cost you are spending is for meeting of the customer service, customer responsiveness. That additional cost which will also be considered here, right? So the overall customer service, whatever the best service a company wants to provide to their customers, with any given least total cost system design. So you want to provide the best service at the least possible cost. This combination, normally we call it as a threshold service level. Threshold service level where you're providing the best service with the minimum possible cost. So here we can say it is a win-win situation for a company and as well as a customer. Threshold service, to establish a threshold service level. What we have to do, what a logistics role here, it is necessary to initiate the network re-engineering with policies regarding desired inventory availability and capability. So it is a common practice to have the customer service capability based on the existing order entry and the processing system, warehouse operations based on standard order fulfillment at existing facility, and transportation delivery time based on capabilities of at least the least cost response transportation method. So given these assumptions, what are the assumptions I have made it here? Customer service capability, warehouse operations, and the transportation. With these three assumptions, existing performance is a starting point for evaluating the potential service improvement. Say if the safety stock availability goal is established, a company is keeping 97%. If you keep the stock, safety stock, the performance of customer responsiveness is 97%. So if that is a way, we need to fix it. So given the initial assumptions, each customer is assigned a shipment location on the basis of the least total cost. In the multi-product situation, selection of service territory for each facility will depend on the products, how you are stocked in the various warehouses, and the degree of consolidation required by the customers. Because costs have significant geographical differentials, the service area for any given facility, which will vary the size of the configuration. So in addition to what we can do now is, the company can also do a service sensitivity analysis. As we know, the threshold service resulting from the least total logistical design provides a basis for a sensitivity analysis. So the basic service capabilities of a network can be increased or decreased by variations in the number of warehouses, change in one or more performance cycle, to increase the speed or consistency of operation. And even the company can go in for changing this safety stock policy. All these will help the firm to keep threshold service. What other things could be done? The company can also think of locational modification. The warehouse structure of logistics system establishes the services that can be realized without changing the performance cycle or safety stock policy. Maybe I'll give you the example. The first one, incremental service is a diminishing function. Incremental service is a diminishing function. How? The first 5 warehouse locations which are providing 24-hour performance, which relates to 42% of all customers. To double the percentage of 24-hour service from 42 to 84%, 9 additional warehouses are required. So already we are having 5 warehouses which are providing 42% of the services, even if they are doing it round the clock, 24 hours. If they want to improve the performance of performance towards customer from 42 to 84%, double the performance level, the company has to go in for additional 9 warehouse systems. So this is one way of doing better service. The second one, high degree of services are achieved much faster for longer performance interval than for the shorter interval. I'll give you an example. 4 warehouse locations which are providing 85% performance within 96-hour performance cycle. This is a data. Increasing the total locations from 4 to 14 in the earlier case improved the 96-hour performance by only 9%. So earlier, what we discussed, within a total of 14 warehouses, they achieve 85% given in the 24-hour performance cycle. If you increase the number of total warehouses with the performance hour from 24 to 96, there is no much increase in the service level. So which means this kind of decision, increasing the number of warehousing decision, which will have an impact only in the long duration rather than the short duration. That's the point I want to make it clear. Then the total cost associated with each location added to logistic network, which increases dramatically. So when you look at the incremental service resulting from additional locations, which will diminishes. So when we say whatever the new facility you are adding, the service payoff we are adding, which is related with cost. So what the logistics managers have to do, they're often asked to estimate the inventory impact of adding or deleting a warehouse. So what is the role of a logistics managers here? They have to estimate the inventory impact of adding or deleting the warehouses. So this relationship between uncertainty and required inventory is called portfolio effect. What is this called? The relationship between uncertainty and the required inventory. Uncertain versus the required inventory. This is called normally the portfolio effect. This portfolio effect can be estimated using the square root rule. We are applying a formula for this using a square root rule, which was originally proposed by Meister. He suggests that the safety stock increases as a result of adding a new warehouse, which is equal to the ratio of square root of the number of locations in the newly prepared network divided by square root of the number of existing locations. So this is only an information, don't bother much about it. To make this kind of decisions, we are using a square root rule. Then we move on to performance cycle modification. Speed and consistency of service can be varied to specific market or specific customer by modification of some aspects of performance cycle. To improve the service, electronic ordering and any premium transportation can be used. So geographical proximity and the number of warehouses do not equate directly to fast or consistent delivery. This is the point with the example I have explained. So the decision to increase the service by adapting a faster performance cycle arrangement will typically increase the variable cost. In contrast, the service improvement by virtue of adding any number of warehouses involves high degree of fixed cost and could result in less overall system flexibility. So no generalization can be offered. Which one should be given higher priority? Cost versus service, right? So this typical relationship of premium to lowest cost transportation, we consider this performance cycle. Then how to finalize a strategy? So before finalizing, the company can also think of modifying their safety stock position. It's a direct way to change the service to increase or decrease the amount of safety stock. So this impact of increasing the safety stock across a total system will shift the average inventory cost curve upward. So a goal of increasing customer service availability will result in increased safety stock at each warehouses. So, how to finalize a strategy? Management often falls into the trap of being overly optimistic in terms of service commitments to customers. The result may excessively higher customer expectations followed by erratic performance. So, in part, such overcommitment results from lack of understanding of the total cost required to support, and of course, a zero defect service also. So, how to arrive a final strategy? So, the final step in establishing strategy is to evaluate the cost of incremental service in terms of generating offset in the revenue. I'll just explain it with an example. Assume that the current system is geared to service at least 90% of all the customers at 95% inventory availability. So performance cycle percentage is 90, and they are keeping available material up in the inventory up to 95% within 60 hours of order receipt. Within 60 hours of order receipt. Furthermore, assume that the current logistical system is meeting these objectives at the lowest total cost by utilizing a network of 5 warehouses. So this is a scenario. But what is happening here is the marketing, however, is not satisfied and believes that service capability should be increased from 90% to 97%, which will directly impact the inventory availability, and they also wants to serve the customers within 24 hours instead of the 60 hours. So now we have to think of how the logistical management needs to estimate the cost of increasing the service commitment from 90 to 97%, as well as reducing the performance cycle hour from 60 hours to 24 hours. And the next point under this discussion is maximum service. Maximum service strategy is rarely implemented because a system designed to provide maximum service shifts the design emphasis from cost to availability and delivery performance. Maximum service area can be developed similar to the least cost service area. So maximum service area, the maybe as with the cost service area are determined. It may be cost oriented service area or time oriented service area will be irregular because of the transport route configurations. Then mostly companies are looking for maximum profit. Most enterprises aspire to maximize the profit in the design of logistical system. Theoretically, the service area of each warehouse should be determined by establishing a minimum profit contribution for customers located at varying distances from the facility. Because the warehouses are normally located near high volume markets, the greater the distance a customer is located from the service area, generally the higher the cost of logistics. So this cost increase occurs not only because of the distance, but also because of the lower customer density at the periphery of the warehouse service area. So now at this point where the cost of serving peripheral customers results in minimum allowable profit margin. And at one point of time, this further extensions of the service to lower peripheral customer segment become unprofitable total cost delivered basis. So if the customer were provided with improved service, it is possible that it would purchase more of the overall product assortment sold by a firm. So if in a theory, if you see, additional service should be introduced to the point where marginally generated revenue equals marginal costs. At this point of equilibrium, where our marginally generated revenues equals the marginal cost. At this point of equilibrium, no additional service would be justified. And here, the additional service may or may not result from increasing the number of warehouses. So the desired service might be provided best by supplemental delivery system using a direct or any kind of dual distribution. So what is the final conclusion? Which kind of decision has to be taken by the firm to keep a competitive logistic decision? Either we have two ways. One, we can go with maximizing competitive advantage. Second, we go with minimizing asset deployment. Under special situations, most desirable strategy is to guide logistical system design. It may be to seek maximum competitive advantage, which can be achieved through segmental service, a common modification in the least cost design, and consist of improving the service to protect major customers from competitive inroad. So where segmental service can be possible. Say, for example, if the existing service policy is only capable of providing 42% of the customer with 24-hour delivery at 95% inventory availability. So this is the statistics available at present. Care must be taken to be sure that the most profitable customers are getting the best service possible. So this is one way of doing this. Second one, justified high cost warehouse. An additional application of the design modification to capitalize during the competitive situation is an economically justified high cost warehouse. This situation is pertinent especially to smaller or Nike niche businesses, because of the rigidities inherent in larger firms. Pricing policy are also likely to be inflexible. So antitrust legislation reinforces sometimes this kind of rigidities. The result is that large firms selling in broad geographical markets tend to disregard unique costs, where they need to concentrate on their small market, that is niche market. So they can use this specific high cost warehouse strategy. So these two strategies, what I discussed with you under the head of maximizing the competitive advantage. How do we do minimizing the asset deployment? Your final logistics strategy may be motivated by a desire to minimize the assets committed to the logistics system. A firm that desires to maintain maximum flexibility may use variable cost logistical component, maybe such as public warehouses and for higher transportation. Such a strategy might result in higher total logistical cost than it could be realized by asset commitment to obtain economies of scale. However, the risk could be less and the strategy would increase the overall flexibility. So, integration of logistics strategy to support the overall enterprise operations, which requires precise customer service commitment. So from the viewpoint of designing a perfect integrated logistical system, your total least cost and threshold services offer an ideal platform for undertaking cost versus service sensitivity analysis. So to conclude, summarizing the context of integrated logistics, what we have seen so far. The primary determinants of logistics network design are established by integrated procurement strategies, manufacturing strategies, and market distribution strategies. So within this framework of interlocking strategies, logistics requirements are satisfied by blending of transportation and the inventory capabilities. And when we talk about total cost integration in the specific discussion from the beginning, what we had is total cost integration, which provides a framework for simultaneous integration of logistics, manufacturing, and procurement cost. So total cost analysis provides the methodology for integrating the cost across the network. And the accurate total cost analysis is not without any practical problems. Foremost is the fact that a great many part and cost are not specifically measured or even reported by standard accounting systems. A second problem involved in total cost analysis is a need to consider a wide variety of network design alternatives. So to develop a complete analysis of planning, situation, alternative shipment sizes, mode of shipment, and range of available warehouse locations, the factors also needs to be considered. The problem can be normally be overcome if a care is taken in the network analysis. The cost format recommended for total cost analysis is to group all functional costs associated with inventory and transportation. So what is required here? The total cost integration provides a simultaneous analysis, time and the space related cost. We concentrate time and the space related cost in the overall logistical network design. These are all some of the concepts which we have seen under the heads of integrated logistics 1 and 2. So logistic, what is next to summarize the other content, what we have seen today, logistical strategy, how to arrive a final logistic strategy. It requires the total cost analysis be evaluated in terms of customer service performance. So logistical service is measured in terms of availability, capability, and quality of the performance what the company is delivering to their customer. And the ultimate realization of each service attribute is directly related to our logistical network design. Say highest level of logistic operation support, or when we talk about the overall integration, customers should be provided service to the point where marginal cost equates the marginal revenue. This is the point I stressed even when we had a discussion. Such marginal equalization is very hard to achieve. In practical, it is very hard to achieve. But that's a primary goal of any integrated logistics scope. So the formulation of a service policy, starting from analyzing, identifying the least total cost design. So we identified what is a threshold service where the marginal cost meets the marginal revenue. And the last part of our discussion, what we had to evaluate the potential modifications. Whenever you want to make any changes in the cost design, we use sensitivity analysis, root cause analysis and all. So how the service levels can be improved by reducing the cost, which also we discussed, the variations in the number of facilities, change in one or more aspects of the performance cycle, or changes happening in the safety stock. So these are the three ways where better service customer responsiveness can be achieved with the least possible cost. I'll just give the points once again for your clear understanding. Variation in the number of facilities, changes in one or more aspects of the performance cycle, and changes in the safety stock level. So beyond least cost design, four potential strategies. We also discussed the maximum service, the maximum profit, maximum competitive advantage, and minimum asset deployment. These are the four major strategies which we had our discussion. Maximum service, maximum profit, maximum competitive advantage, and minimum asset deployment. So among the range of strategic options, the four strategic options, the end objective of any logistical systems design is to select a logistics strategy that always supports the overall business strategy of the organization. So this is a point I want to make it very clear. Whatever the logistical integrated strategy we are thinking about, which will always be oriented with the overall business strategy. I hope in this lesson we discussed how a company has to achieve an integrated logistics in way of achieving the threshold performance by considering cost as one side aspect, performance and customer service responsiveness as the other aspect. I hope this discussion clearly gives you a clear understanding of the entire integrated logistics concept. Thank you for listening. Keep continuing your happy learning.